Welcome back to our discussion about graphing trig functions. And in this video, we're going to talk about how do you actually graph the cosine function. So we've looked at how it's derived, and we've looked at some transformation work with the cosine function. And now we're going to actually take the equation of a cosine function and come up with a table and go ahead and plot the points and graph the curve. So similar to what we did with our sine function, when we're given a function, we want to identify the key attributes of the graph, including all transformations. So let's go ahead and look at this function. F of t is equal to 1/2 the cosine of 2t minus pi. We know right away that our amplitude will be 1/2, so that's very easy. And we know that there's no reflection, because if there was a reflection, we would have a negative in front of that 1/2. Okay, we can use the b value to come up with our period, because remember that we know that 2 pi divided by b will give us the period. And so 2 pi divided by 2 will give us pi. And then we can use that period to come up with the increment between our quarter points, because we can take that period and divide it by 4. Pi divided by 4 will give us our increment. Now, if I take my c value and negate it, so negative pi, and divide it by 2, that will give us our phase shift, negative c over b. So we have negative pi divided by 2, which gives us pi over 2 as our phase shift. So this graph has been shifted pi over 2 units to the right. And of course, there is no vertical shift, because after the argument of cosine, there is no plus or minus here. So no vertical shift at all. So we can use these attributes to come up with a table of values, which will allow us then to plot points. Remember that we are going to start our t values with the phase shift, which is pi over 2. So that's going to be our initial t value. And then we're going to use our increment and count up from that initial value. So we're going to count up by pi over 4 from pi over 2. And in order to do that well, we are going to think of this pi over 2 as 2 pi over 4, because then we can add pi over 4 and get 3 pi over 4, 4 pi over 4, which is reduced to pi, 5 pi over 4, and 6 pi over 4, which reduces to 3 pi over 2. Now we're going to recall the pattern of the cosine graph. Remember that it starts at the max and then goes to the middle, then down to the minimum, back to the middle, and then back to the max. So this has a slightly different pattern than sine. So we're going to go ahead and fill in all those middle points with our vertical shift, which is 0, and then use our amplitude to find the max and the min. So we're going to add 1/2 to find our max and subtract 1/2 to find our mins. Now we're going to continue this pattern and subtract pi over 4. So subtracting pi over 4 from pi over 2 will give us a pi over 4, a 0, a negative pi over 4, and a negative pi over 2. And then we can continue our pattern for our y values, our f of t values. So every other y value will be a 0. And then the other values will alternate between negative 1/2 and positive 1/2. So now I have my table ready, so I can go ahead and plot these points on a coordinate plane. And when I do that, I see these nice points emerging. It does look zigzaggy when I just plot my points. But then remember that as I sketch my curve, I'm going to make it a nice smooth wave curve. And this will be our cosine graph. Okay, well done. Let's look at one more example like this. Here we go. f of t is equal to negative 2 times the cosine of 2t minus pi over 2 plus 1. So going through this function and finding our key attributes, the amplitude of this will definitely be the absolute value of negative 2, which is 2. We can say definitely there is a reflection over the x-axis because of that negative. Our period, that will be 2 pi divided by b, which is 2. And we can reduce that to make it pi. Taking that period and dividing it by 4 will give us the increment between our quarter points. And then we can determine our phase shift by taking negative c and dividing it by b. So negative pi over 2 divided by 2 will give us a positive pi over 4. And then last, our vertical shift is a plus 1. All right, so let's go ahead and find our t values. We're going to start at our phase shift, which is pi over 4. And we're going to count by pi over 4. So pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi, and 5 pi over 4. Now, let's remember what's going on with our cosine function. Our reflected cosine function is going to start, instead of the max, it's going to start at the minimum. And it will go from the minimum to the middle, and then up to the max, and then back down to the middle, and then back down to the minimum. Okay, so we're going to fill in those middle values with our vertical shift. Okay, so our middle values are now 1. And then we're going to use our amplitude to determine our max and our min. So we're going to add 2 to that 1 to get our max, and we will subtract 2 from that 1 to get our minimum. So now I'm able to continue this pattern backwards with my t's by subtracting pi over 4 times. So I would have 0, negative pi over 4, negative pi over 2, and negative 3 pi over 4. And then continuing my pattern for my y values by adding a couple more midpoints in there, midlines, and then a max and a min. And then as we go ahead and plot those points, we can see our pattern emerge. And then we can sketch the curve between them, making sure that it looks like a wave. And this is a very nice cosine graph that we can see has been shifted up 1 and shifted to the right pi over 4. All right, that does it for today and the cosine function. Stay tuned for a little more later.